secretary, and today I'll be showing you how to use OpenRocket. So the first thing you note is that over here we have our entire rocket design hierarchy. And for now we can get started by going here, clicking on the sustainer, and clicking body tube. So for now you can close this, and over here you'll have your diameter. So whenever you make your rocket, specifically for torque, you'll be able to change this. So if I were to put this in centimeters, you could go in and change it, but for now let's keep it at the default height, or sorry, default diameter, which is 1.969. Next we'll add our nose cone. Click, you can close that, press OK. Now see how it is currently underneath our body tube. You can change this by going into the rocket hierarchy and just dragging it up. And also, if you double click on the nose cone, you can change your nose cone shape. So you can make it an ellipsoid, which is what we typically use. You have some other ones like a power series or a parabolic series, but typically we use ellipsoid. Also over here you can change like the base diameter, so you make it wider, or you could also, sec, or you could also make it longer, like this. Yeah. Next we'll make another. Oops. Next, click back on the sustainer, and we'll make another body tube. Press OK. And now to add on to this body tube, we'll go down here, find body components and fin sets, and click trapezoidal fins. And personally, I like to use 4 fins, so I'm going to add 4 fins here. Press OK. Now there are some important things to note. Down here in this lower section, you have your rocket body length, which is 22 point, or at least for me, it's 22. And here you have your max diameter of 1.969. And then you also have your mass here. And on this right side, you have your stability, which is negative 2.65%, or which you don't want to have. And you'll have your center of gravity and center of pressure. Now, to change these units, because you could see these grams in something else, or these inches in centimeters, or stability in calibers. So you could go here to edit, edit, preferences, units. Over here you can change any of these. So you can go from percent to calibers. I'm gonna keep mine in percent for now, but typically a good stability to have is anywhere between 8% and 18%, or from 1.5 calibers to 2 calibers. So I'm going to close this for now. And right now I do not want our stability to be this low. So some of the ways you can change this is by increasing the root chord, which is essentially the length of that base you see there. Or you could change the height, which will make the fins taller. Or you could change the tip chord, which is essentially that angle, that top right angle. So I can put it at like, I'll keep it at a 90-degree angle, so 1.6, or sorry, 2.2. And you have a root chord here, which essentially is the angle of that bottom part that you see, right? So I'm just gonna press cancel. But yeah, that's how you can change the stability there. And another way you can change your stability is if I go to nose cone, or you could click on any body part really. But if I click on nose cone, I can click on the mass component here, and I'll just set this to 50 grams, right? And over here, you have your placement thing. So what this basically means is it says position relative to, or relative to. So here it says top of parent component. So if I look over here, the parent component for the mass component is the nose cone. So now if I drag this, it says plus 3 inches. So when I move it down, you can see that this center of gravity, which is also kind of where the middle of a rocket is, for mass is, right? So if I were to move my mass component, let's move it down here. It's at 50 grams. Now that our center of gravity is higher up because we added mass on this side, our stability has also went up. So your stability can go up when you add more mass on this side, but it can also go down when you add more mass on this side. So now that I have that, the next thing that you should know is if you go over here to motors and configurations, I'm going to click on the lower body tube because that is where your motor will be. And if you click on new configuration, I already have it shown here, so let me delete this. You'll see a menu that looks like this. Now in the Aerospace Club, we will use F42s. So click on or type in F42, select Aerotech, F42T/L, press OK. Now you see you have a motor here, and now there's some things to look at. First off, you can see that we now have two mass measurements, one with our motor and one without, and our stability has also went down because we added a motor. So if we want to bring our stability back up, we can increase our mass. And now you see it is at 16.5, which is a good stability. Also over here, we have our apogee, which is 1,662 feet, which is essentially the highest our rocket will go. And the other stuff you do not really need to worry about. So now we can go over here to flight simulations. So over in flight simulations, let's make a new simulation and type simulate and plot and click plot again. So as you can see here, we have a nice parabolic curve. And you see here your apogee is 1,662 feet, which matches what we see over here, right? So now what if you don't want a parabolic curve? Because according to the parabolic curve, you are going to essentially just be going and crashing straight back down. In order to prevent that, what you want to do is go back to your rocket design, click on your lower body tube, and add a parachute and also a shock cord. What your shock cord essentially is just the rope that connects your parachute to your lower body tube. So if I move this down here, let's move this a bit further down. Alright, so now you can see it. Let's put the parachute at, let's say, 21 inches. Okay, now if I were to go back to flight simulations, run simulation, and plot it, you can see now that I have more of an instant rise, and then it kind of just like drags down, and you can zoom onto it if you want to kind of see closer. And you can right click it and drag to kind of scale the axes. So let's close this, and essentially what that shows is, one sec, essentially, if I go plot here, this lower axis is your time. So from here we can see that it takes a little over 80 seconds, but also if we check here on the right side, it says flight time, it'll say 83 seconds. Now if I get rid of this, right, and we go to flight simulations, run simulation, you can see here that it says we will have a time of 21.3 seconds. So if you want to increase your time, you can add a parachute, and if you want to adjust your time after you add a parachute, if you decrease the diameter, you will lower the amount of time that your rocket takes. If you increase the diameter of the parachute, then you will increase the amount of flight time you have. So let's add that parachute back. So I will show you what I mean by that. So right now, when you run it, it was at 83. If I were to decrease the diameter to maybe it is 7.9 inches. Now if we go here and click run simulation, you can see that now it is 39.2 seconds. So that is how changing our parachute diameter can change our flight time. So now here, let's go to our upper body tube and click tube coupler. What a tube coupler does is essentially it'll bring both of our body tubes together, because right now there's nothing holding them together. So if we go down here and let's move our tube coupler to the middle of these two, so it's like kind of in the middle of both of them. So essentially what this will enable you to do is whenever you're building a rocket, you'll be able to drill holes into your rocket and then add screws in, and then this tube coupler will essentially act as like a joining component between both of them, because it'll have screws on both sides on both the upper tube side and the lower body tube side. So then let's also increase the diameter here to 1.85 so that it's touching the walls, just so that we have enough space as we can inside, and so that we have we don't risk it being shaken around or anything like that. So then after you do that, there's one last thing we need to do. Let's go over here to your nose cone and click shoulder. So if I were to increase the length of this shoulder, you can see that it's kind of like a stick that juts out from the nose cone. If I were to increase the diameter, you can actually see that it's more of a cylinder here. So let's set this to 1.85, the same as our tube coupler. What this essentially does is the same thing as your tube coupler here, except it is binding your nose cone to your upper body tube. And once you add screws, it'll be officially binding it because the screws won't let it move. If you don't add the screws, there'll still be a lot of friction over here, so your nose cone won't fall off as easily. Um, so now that we have that, there's one last thing that you need to do. If you go here and click PLA here, you can see our mass will change, and the reason why we're doing that is because when you CAD your fin can, it obviously won't be made out of wood. So in order to adjust for that, you want to change your component material here to PLA. However, most of you guys will not see that option. So in order to add that option, you want to go to custom, and then it'll open up this little window here where it says material name, PLA, and then you want to enter PLA 100% info, and it'll also say material density here, and you want to enter 0.723 ounces per inches cubed. And then you want to click add material to database and type and press OK. Um, that'll be it for this video. Thank you guys for watching.